In this video, we will explore how to avoid 5 common math mistakes. Ultimately, by avoiding these mistakes, you'll become a lot better at math. The first question asks, if cosine x is equal to 1, then does x equal to 1 over cosine? The short answer to this question is no. Now let's explore why. Remember that cosine is a comparison of the adjacent length to the hypotenuse length. Take, for example, this right triangle, and we have an angle that represents this line. Now, cosine is a comparison of this length right here, the adjacent, over the hypotenuse. And every angle ranging from 0 all the way to 360 will have a specific ratio. If we take those ratios and we were to plot them relative to the angle, so here we have our angle, and here we have the ratios that represents the y-axis, we would end up with a wave that looks like this, one that starts at 1, makes its way down to -1, and then goes back up to 1. So cosine means nothing if there's no input of an angle. It has no meaning. So when you go into your calculator and type in cosine and an angle, what it actually does is it will give you the ratio that represents that angle. Now the opposite is true when you use cosine inverse, this strange symbol that you also find on your calculator. So what mathematicians have done is that they've developed a function that when you put the ratio, it will give you back an angle. So in our case here, this 1 represents a ratio. And to find out the angle x that represents the 1, you would actually have to use cosine inverse of 1, and it would give you the angle. Now, according to this wave, we know that the angle that our calculator would give us would be 0 degrees, because only at 0 degrees will we get 1, and of course, repeating at 2 pi or 360 degrees. And the same thing goes for all trigonometric functions, including their reciprocals. Let's move on to mistake number 2. The question asks, does x plus 3 to the power of 2 equal to x squared plus 9? And the answer to this is no. Now, presumably what the person did was they took this exponent and they distributed it to the two terms in this bracket. Now, you cannot do that mathematically. Instead, what you do is you take those two terms, x plus 3, and you multiply it in itself twice. And here what you would do is you would expand. And to expand, you would use the distributive law, which means you multiply this x with these two terms and this 3 with these two terms. And that would give you x squared plus 6x plus 9. Notice the difference between this expression and the final expression. The confusion for this comes from the fact that in the laws of exponents, you have this rule called the power to a power. It looks like this. So for example, let's say you had 4x y to the power of 2. Here what you would do is you take this 2 and you would distribute it to every component inside the brackets. But notice the difference between this example and the previous one. This expression had two terms, and this expression has a single term. There's no other term after the 4xy, and so therefore this would be 16x squared y squared. Let's move on to mistake number 3. Here they're saying, does the square root of x squared minus 4 equal to x minus 2? And the answer to this is no. Now let's explore why. Remember, see this radical symbol right here? This radical symbol actually represents fractional exponents. In other words, this x squared minus 4 actually has a power of half, a fractional exponent. Mathematicians devised a way to show fractional exponents by using this symbol called a radical. And this actually goes back to our previous example, where in our previous example, we learned that you cannot distribute the exponent when you have an expression with more than one term. So presumably what the person did was they took each of these terms and gave it their own radical, which is mathematically invalid. Now let's move on to mistake 4. Does bracket 5x bracket squared equal to the following two? And it actually equals to neither. Notice that this bracket is surrounding the -5 and x. So what that means is that you're taking -5x and you're multiplying it twice. And if we do that, we end up with -5 times -5. Two negatives make a positive 25. And the two x's make x squared. Notice the difference. This is the right answer, and these two are wrong. The only way you would end up with negative 25x squared is if you put those brackets in between the 5 and the x. Only then will this 2 distribute to the 5 and to the x, where you end up with negative 25x squared. Whereas in our case, we have negative 5x power to 2, and this 2 is actually being distributed to this negative, which literally represents negative 1, this 5, and this x. So you have negative 1 to the power of 2, 5 to the power of 2, and x to the power of 2. Notice we have positive 25x squared. In our last example, does x over x plus 2 equal to half? Now this is a very common mistake made by students. Notice what we have here. We have a single algebraic expression at the top known as a monomial, and at the bottom we have two terms in this algebraic expression. One of the terms is x and one of the terms is 2. And presumably what the person did was they canceled out this x with this x, leaving them with half. That is impossible to do, and the reason why students make this mistake is because they confuse it with one of the laws of exponents called the quotient rule. The quotient rule says this. Let's take, for example, 4x over x. Now here we have a single term at the top and a single term at the bottom. You can cancel out the x's in this situation and you'd end up with 4. However, if we had 4x plus 2 over x, you can no longer just simply cancel out this x with this x. That doesn't work because now you have an algebraic expression at the top with two terms. So technically, this x actually belongs to these two terms. So this expression actually looks like this, where you would cancel out this x, but here you would end up with 4 plus 2 over x. So do not make this error. If you ever notice that there are multiple terms at the top or at the bottom and only a single term at the bottom or the top, you cannot perform the canceling out method. So there you have it. 5 common errors that when avoided will make you better at math. So the more you practice, the less likely you'll make them. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.